Hello, my name is Alex Shestopalov, and I'm a faculty at the Department of Chemical Engineering at the University of Rochester. And I conduct research on advanced functional interfaces and high-resolution patterning techniques. So the main theme of our lab work is that we want to have a control over the properties of material interfaces. And by controlling the properties of interfaces, we can then control the actual physical and chemical properties of the materials as a whole, and also the devices that are made out of these materials. So, for example, we're working on the surface functionalization techniques that can modify the surfaces of inorganic and organic materials. And by doing these modifications, we can also then modify various physical and chemical properties of the materials. So, for example, we can modify interfaces of materials that are used in thin film electronic devices, and by changing these interfaces, we can then control charge transfer dynamics between different layers of the devices. We also work in collaboration with other professors at the University of Rochester on modifying surfaces of biomedical devices and materials. So, for example, in sensing and diagnostics, we develop methods that allows us to create interfaces that are really stable at conditions when you analyze biological samples, and at the same time, these interfaces, they are chemically specific to certain analytes that you have in the solution. So then you can trap this analytes at the interfaces and then detect the amounts of these analytes in solution using other methods. We also conduct research on high-resolution patterning techniques for biomedical applications or for electronic applications. We developed a printing technique that allows us to print molecules, thin films, inorganic materials at high resolution below sub-micrometer using shape memory materials and contact transfer techniques. So these types of printing techniques can be applied, for example, to make high resolution organic light emitting diodes or micro light emitting diodes for display applications. And also they can be used in biomedical applications to create arrays of biosensors. And another area of our research relates to optical materials and improving the performance of optical materials when they are exposed to high power laser radiation. So the development of high power lasers is really related to the damage resistance of optical materials. And in our work, by analyzing what happens at the interfaces of optical materials, how the interface changes chemically and physically, we can then figure out processes that will allow us to preserve these interfaces and reduce the damage of these optical materials when they are exposed to high power laser radiation. So in general, the entire research that we do in the lab, it's at the interfaces of different materials. We functionalize interfaces. We develop coating techniques for thin films that can be applied to interfaces to change their properties. And we also develop techniques that can pattern interfaces at high resolution with different structures for electronic, optical applications, biotechnological applications.